This is 6.5, day 1, part 2. We've just done a few problems already where we're solving for the roots or the zeros or the x-intercepts of the function. So we have another example. This one I'd say you might want to listen, and then we have one left, question F. So we want to use that chart method again. So we say, what are the factors I lost my smartboard connection there. What are the factors of C, which is 21, that adds to B, which is negative 10? So we would say 7 times 3 is 21. When we add that, we get 10. Nope, that didn't work. Try negative 7 times negative 3. When I add those together, I get negative 10. And yep, that's the one that we want. So these are the numbers we're going to work with. So we split up the trinomial into 2 parentheses, and it's a degree of 4. So we split up the first 2 terms as x squared and x squared. And then the next 2 terms are from what I have circled, negative 7 and negative 3. And now we solve those separately using the zero product property. X squared minus 7 equals 0, and x squared minus 3 equals 0. Now solve by undoing to finish up these equations. Undo by adding 7, and then square root it. So you get plus or minus 7. And then over here, x squared equals 3. Square root it, plus or minus 3. Last example. This one I would recommend you write down if you didn't write the last one. Another method of using that T-chart . So we'd say, what are the factors of C that add to B? And we list out some possibilities. 6 times 4, which adds to 10. 12 times 2, which adds to 14. Negative 6 times negative 4 adds to negative 10. Well, there's the one that works. So those are the values we're going to use. So we split up the x squared and the x squared, and then minus 6 and minus 4. Now use the zero product property to solve for x. X squared equals 6, so then x equals plus or minus the square root of 6. And then solve by undoing x squared equals 4. So then x equals plus or minus the square root of 4, which is a perfect. So plus or minus 4 reduces to plus or minus 2. Okay, this example, let's say we get to factoring, and it looks like this. We have x squared plus 5, and then x squared minus 6. So we've done the T-chart already. And then we break it off into its factoring. So we'd say x squared plus 5 equals 0, and then x squared minus 6 equals 0. Here's a little problem that comes up with the first equation. When I solve by undoing, I would subtract 5, and then I would square root it. What's important about that negative 5? You can't have a negative square root, so it makes it imaginary or complex. So remember, from earlier in our chapters, we replaced that negative with an I out in front, and then 5. This is called a complex 0. We learned earlier in our class that a complex zero is not an x-intercept on the graph. So we still have zeros, they're just imaginary or complex zeros. Finish off this equation, add 6, square root it. And that one is okay. So we actually only have x-intercepts at plus or minus 6. This one over here does not give us x-intercepts. So even though we have a quartic equation, which is a degree of 4, we only have 2 x-intercepts. We still have 4 zeros, or roots. 2 of them are real, and 2 are imaginary or complex. This will be the lesson assignment for 6.5 day 1. On page 442, we do problems 2 through 14, and then 23.